Hey everyone, welcome back to Cracking the GRE Math Subject Test. We're on number theory and abstract algebra. This is the first question. This question is checking if you know how to solve what's called the diophantine equation. This equation right here is called the diophantine equation, and it's one of the first things you learn in number theory is how to solve this kind of equation. So the trick here is first of all, to use the Euclidean algorithm to find the greatest common factor between 55 and 42, and then you kind of use it backwards to figure out what x and y are. I'll show you what I mean. Okay, so first of all, we'll use the Euclidean, I'll write it here, Euclidean algorithm to find. So here's the first step. Find the greatest common divisor of 42 and 55. Alright, so this is what you do. You write 55 is equal to 42 times some number, I don't know what it is, plus some remainder. So let's think. 42 goes into 55 just one time, so we're going to write 1. And the remainder is 13. Okay? Now the next part is taking this number, 42. Okay, I'm going to write it over here. Equals, and you have to write it as, do the same thing but with 13. So 13 is going to go here. So 13 times some number plus some remainder. So how many times does 13 go into 42? 3 times. Because 13 times 3 is 39, and then the remainder is going to be 3. Okay, now we do this again. We're going to write 13 is equal to, and we're going to put this 3 over here, 3 times something plus a remainder. Well, 3 goes into 13 4 times. That's 3 times 4 is 12. And then the remainder is going to be 1. Well, once you get to 1, well, that's the end of it, because you can't have a greatest common divisor that's less than 1. Okay, so we're done with this part, and we know then that 1 is the greatest common divisor. Okay? In other words, 42 and 55 are relatively prime. Now we're going to use this information to find the solution to the equation. So we're going to work our way backwards. Okay, and I'm going to work from the bottom to the top. Okay, so here's the first step. I'm going to write 1 equals 13 minus 3 times 4. Okay. Now this 3 right here, I'm going to rewrite using this equation as 42 minus 13 times 3. Okay, so let's try that. 1 is equal to, this is the same, 13 minus, now here we're going to write 42 minus 13 times 3. And all of this gets multiplied by 4. Well, let's simplify this. 1 equals the 13. If you notice, you have 13, and then you have minus negative 13 times 3 times 4. So that's like 12 times 13. So 13 minus negative 12 times 13, that's like positive 13 times 13. And then we have minus 42 times 4. Okay. Now we're going to use this equation to write 13 as 55 minus 42 times 1. Okay, so I'm going to continue. This is a arrow. So we're going to go 1 is equal to 13 times, let's use a different color, 55 minus 42 and then all of this minus 42 times 4. That's from over here. Okay, well, let's simplify this. If we simplify, we get 1 is equal to 13 times 55 and then we have minus 13 times 42 minus 4 times 42. So that gives us minus 17 times 42. So our answer is x could be minus 17 and y could be 13. This is x and y. That's one answer that satisfies this equation. But the problem is actually asking us for a value of x that's between 100 and 200. And so we're not done yet. So this set of values, x equals negative 17 and y equals 13, that gives us one solution. But there's actually infinitely many solutions. And I'll show you why. Here, let's write this equation. We have negative 17 times, what was it, 42 plus 13 times 55 equals 1. Now, if we add 0 to the left side of the equation, that doesn't change anything. So one way of adding 0 is to add 42 times 55 and subtract 42 times 55. Well, how can we do that? If we take negative 17 and add to it a multiple of 55, and at the same time we'll take 13 and subtract from it the same multiple of 42, then that's like adding 42 times 55 over here and subtracting 42 times 55 over here. So that won't change your answer. So actually, our general solution is any pair of integers, x and y, of the form negative 17 plus 55 times some integer t, and 13 minus 42 times some integer t. So if we're looking for a value of x that is between 100 and 200, then we have to think what value of t will give us an integer between 100 and 200. And I think that if we set t is equal to 3, then we'll get negative 17 plus 55 times 3. Well, 55 times 3 is 165. And 165 minus 17, that's equal to 148. And is that one of our answers? Yes. That is answer B, 148.